We all know the story of electric vehicles, and it's a success story. But electrifying personal transport is only half the battle in the fight against climate change and for securing a stable national energy future away from finite, highly consumed fossil fuels. A significant roadblock to a 100% clean grid isn't the family car. It's also heavy-duty transport. Current battery technology, while great for cars, is often too heavy and large for sectors like aviation, maritime, and long-haul trucking. Despite what electric car companies may claim, the rate at which electricity can be delivered is limited by physics. But the rate at which energy transfers into a vehicle using hydrogen is significantly higher than electricity could ever be. This is one of the many reasons why so many companies and researchers are looking into hydrogen energy. Hydrogen is the critical missing link that experts believe is essential in reducing our reliance on fossil fuels like oil, natural gas, and coal. So if you're like the average citizen, you've likely never heard of hydrogen energy. And this is all sounds pretty intimidating. So let's break it down in terms you can understand. Hydrogen is an element. It is the most abundant element in the universe. However, it historically hasn't been readily available on Earth. We are still learning about the hydrogen available within our planet, and it could be that there are billions of tons of naturally occurring hydrogen within the Earth. But for now, the most practical way of capturing hydrogen is to produce it using water and electricity through a process called water electrolysis. This process passes electricity through water inside a simple device called an electrolyzer, splitting water into its two components, hydrogen and oxygen. We can capture the hydrogen and store it as a fuel, and the oxygen is released into the atmosphere, as oxygen occurs naturally and abundantly within our atmosphere. The real magic happens when you reverse the process in a device called a fuel cell, which consumes hydrogen and produces electricity. It is essentially the opposite of an electrolyzer. In a fuel cell, hydrogen is combined with oxygen from the atmosphere, producing electricity and clean water vapor, which goes back into the atmosphere and is reintroduced into the naturally occurring water cycle. But hydrogen is more than just a transportation fuel. Its primary role in the clean electrical grid is long-duration energy storage. Renewable energy sources like solar, wind, and hydroelectric dams are intermittent, meaning the sun doesn't shine, the wind doesn't blow, or the water doesn't flow at all times of the day. When they produce more electricity than their customers need, that excess energy can be used to produce and store hydrogen, which can then be converted back to power the grid when renewables are not generating power. This capability balances the grid and ensures a constant supply of clean, cheap power. However, hydrogen does have a major physical challenge: volumetric energy density. It has a very low energy density for its volume, meaning the hydrogen needs to be pressurized or liquefied in order to store enough energy in a small space, like inside a tank in a vehicle or on site for balancing the electrical grid. Hydrogen gas needs to be pressurized by compressing it into a tank. It can also be turned into a liquid by dropping the gas to extremely low temperatures. Hydrogen in its liquid form has more energy per volume, but the process of liquefying it consumes more energy as it has to be cooled to extremely low temperatures. No matter which way you cut it, you'll need additional power to either compress or liquefy hydrogen. Recognizing this potential and these challenges, The US Department of Energy launched the Hydrogen Energy Earthshot in 2021. The goal, known as 111, is to reduce the cost of clean hydrogen production to $1 per 1 kilogram within 1 decade. This cost reduction is being driven by breakthroughs in technology. Research and funding for that research is focused on improving the performance and durability of electrolyzers. Recent reports show significant advancements with electrolyzers achieving efficiencies of 80% and 90%. In simple terms, efficiency is a measure of how little energy is wasted. For decades, a major public barrier has been the notion that hydrogen is extremely dangerous, primarily due to catastrophic events in the past when we didn't have the knowledge to work with hydrogen safely. But this fear is largely a misconception. Studies support that hydrogen is safe compared to gasoline when properly implemented, as hydrogen requires higher temperatures to ignite, roughly double that of gasoline, and quickly disperses upward in the event of a leak, reducing fire risk. Unlike gasoline or natural gas vapors, which can pool and ignite. Environmentally, a hydrogen release produces no harmful emissions like CO2 or other pollutants, and it will not contaminate soil or groundwater, making it cleaner than fossil fuels. In fact, prior to the mid-1950s, gas networks in the US and elsewhere routinely transported and used a blend of gases, sometimes containing as much as 50% hydrogen. If you've ever bought anything online, you've benefited from the use of hydrogen vehicles in fulfillment centers, which distribute purchased goods to consumers. They use forklifts and trucks to move goods around these warehouses. You might be surprised to know that a large portion of fulfillment centers in North America use lift trucks fueled only by hydrogen. Hydrogen is ideal for these systems, where you want your vehicles to be constantly moving and require faster refueling than battery-powered trucks. But you don't want to pollute the enclosed warehouses where your employees work by using fossil fuels. There are over 50,000 fuel cell-powered lift trucks operating across US warehouses. While the exact percentage is difficult to quantify, given the scale of these operations, it is estimated that 30 to 40% of our goods are moved to you using hydrogen vehicles somewhere along the process. This means we have already widely adopted hydrogen vehicles. We just don't always see what goes on behind the scenes. There are currently approximately 35,000 hydrogen vehicles on the roads in South Korea, and that number is increasing due to increased government investments in infrastructure. However, the core challenges remain economic and logistical. Expert consensus points to 3 major barriers to widespread adoption. Number 1, high production costs, meaning the significant electricity cost required to produce hydrogen in an electrolyzer. Number 2, infrastructure. There's a chicken and the egg problem. You need to build infrastructure in order for people and companies to purchase hydrogen vehicles. However, if you don't have the hydrogen vehicles already on the road requiring that infrastructure, then there isn't really a need to install it. Number 3, the need for scale-up, requiring further research and development to manufacture reliable hydrogen technologies in massive quantities. Lastly, another large barrier that isn't very technical, public awareness. Not a lot of people understand hydrogen energy. One way you can make a difference is by sharing this knowledge with your friends and family. A future with less dependence on fossil fuels relies on a multifaceted approach. While electric vehicles handle personal transport, hydrogen is positioned to solve the problems of heavy transport, long-duration energy storage, and industrial decarbonization and manufacturing. With ambitious government incentives and breakthroughs in technology, hydrogen is moving from a niche concept to a core pillar of a resilient, reliable, and sustainable energy future.